2 actions in one singular move. This is Cellfood. We're going to get into a little more detail. How much oxygen does Cellfood create? Well, it depends on the biological oxygen demand of each one of our bodies. Everybody is created differently. Everybody's metabolism is different, and Cellfood therefore reacts differently in every single human body. I may have a lower biological oxygen demand for oxygen than somebody else may have. So Cellfood reacts differently in everybody. On average, we have about a 58% increase in bioavailable oxygen after a 1-hour period through clinical studies, both clinical, analytical, and in vitro and in vivo studies. So a 58% increase. However, I will say that we've done studies where we've seen up to a 300% increase in bioavailable oxygen in people that have a serious biological oxygen demand. This BOD is what determines basically your entire metabolism and that demand that's created for oxygen. So that's basically the biggest part of Cellfood, is creating that bioavailable oxygen. The second part of the program is trace minerals. This is the second part of the 4 specific things, and I'm going to kind of gloss through the trace mineral enzymes and amino acids. But trace minerals, basically, your body can't make them. You have to consume them through the foods that you eat, through the water that you drink. Your body is not able to generate minerals. So when you take a look at what we talk about a periodic element chart, this is all of the elements known to mankind in the universe, 104 different elements, or 109 if you went to MIT. They created their own. I don't know what they're up to. But these are all the elements that are known where I went to school. These are all the elements known to mankind. These are the elements that are in Cellfood. Almost all of them, right? 78 different minerals, trace minerals, 78 of them. You'll notice down here the ones that disappeared down this bottom area are the toxic ones, the things that are radioactive, heavy metals. These things are not a part of Cellfood. So the important notes that you should know about your trace minerals that are in Cellfood, specifically they are plant sourced, they are all organic, they are colloidal in size. This is a big keyword in the nutritional supplement industry over the last half a dozen years. They are colloidal in size, which means that they measure less than a micron. In our case, they're 4 to 7 nanometers. This is extremely important because Cellfood is actually absorbed through the mouth, throat, and esophagus. You may think that you're drinking Cellfood and it goes into the stomach, but that's not the case. Because of the atomic weight of the deuterium sulfate as a base, it actually is absorbed through the mucosal tract. So that's why you're getting such great performance out of the product. It's not going through the digestive tract. Like the counterpart on the minerals, enzymes are proteins that convert other proteins into fats, carbohydrates, and other usable substances for the body. The enzymes must be present in your body for your body to be able to utilize vitamins and other nutrient content. You must have enzymes. Extremely important. Your product, Cellfood, contains 2 different types of enzymes, both metabolic and digestive enzymes. The metabolic enzymes serve as antioxidants. These are the ones that are helping to reduce free radical activity. And the digestive ones are the obvious ones that are secreted through the mouth, throat, and esophagus, and through the intestinal flora area that actually speed up and accelerate digestion. Like the mineral content, they are all plant-sourced in size, or they're actually plant-source based. They're colloidal in size, which gives us a very high absorption rate. One of the interesting things when we talk about how it is that we're able to get this mucosal absorption, an interesting point, I don't have a slide on it, but I should bring it up anyway. Cellfood is an interesting product in that it has a negative charge. You hear about colloidal in size. Well, there's also another measurement when we're talking about nutritional products, and that is the negative charge or the ionic ability for the product to carry a charge. And that's what ionic means. Ionic means that the product itself has a charge, whether it's negative or positive, it has some kind of a charge. So Cellfood actually has a negative charge. Why? Cellfood has a negative charge because the rest of the bodily fluids, which include blood, lymph, saliva, semen, every single human body fluid has a negative charge. When Cellfood is introduced into the mouth, the body perceives it as its own bodily fluid and allows for mucosal absorption and assimilation. Amino acids. I'm not going to spend a whole lot of time on amino acids, just to say that all of our amino acids are free-form amino acids. They do not come from milk proteins. They are also colloidal in size, and there's a total of 17 different amino acids in the product. So some of the different exciting things that I wanted to share with you today, which is kind of unusual because I'm not usually allowed to present these types of things, but I thought I'd bring them along with me just to give you an idea of what cell food looks like in a clinical environment and what cell food looks like in the real world environment. The first study that I want to share with you is something called Zeta potential. When we talked about a product having a colloidal charge, Zeta is one of the measurements that's used in a biomedical laboratory. And you'll see that it measures product stability, product absorption, it measures the ionization or that charge of the group, and it also measures the electrolyte potential, how it increases cellular communication within the human body. We actually enlisted the work of two specific experts, Brookhaven Instruments Corporation and Particle Characterization Laboratories here in America. These are two companies that actually specialize in the testing of these types of products. So we sent out the samples to them. It was kind of an interesting story. We sent them out. About 3 weeks later, we get a call from the first one, from Brookhaven, and they said, you're going to have to send us another sample because something is wrong. We're getting readings that aren't possible. So we said, okay, we'll send you out another couple bottles. Then Particle Characterization Laboratories, Russ called, and he said, there's something wrong with your product. There's something weird here. We're going to have to test it again. Can you send us some other samples? So we said, sure. And at that point, we began to think, this is going to be an interesting study because they're already talking about things that they'd never seen before. So this is what you're looking at. On the left, you're looking at